Hello, everyone. We're Team Fusion from Finastra, and first we want to thank you for the opportunity to present today. We're really excited to share our project with you. So this is our team. We've got Adam Lieberman, Hannah Morgan, IVU, and me, Alon Rossner, and we're all data scientists at the Finastra Innovation Lab. The Innovation Lab is a tight-knit research and development team, and we use data and machine learning to bring proofs of concept to life. And it goes from tackling algorithmic bias to product recommendations in the treasury and capital market space to error detection and correction in the payment industry. We build data-driven solutions across many financial lines of business, and that's our passion. Plain and simple, we love solving data problems with machine learning. But there's a big problem. If we had $1 for every time we were given a perfect high-quality data set, we'd probably have $0. There's really a sophisticated art and science to data collection and curation, and more often than not, data has issues. It's dirty, has missing and incorrect values, outliers, and overall it's incomplete, incorrect, or inconsistent. Data holds secrets, trends, patterns, insights, and so much more, but we need to work with clean, high quality data sets to ensure that we can make the most from it and that it paints the right picture. Besides being dirty, data is often biased. We hear all the time that certain groups and individuals are favored in machine learning models in a discriminatory fashion. And if we model with biased data, we can expect to replicate and predict biased results. Aside from solving problems and building financial machine learning-based products, our lab group is very passionate about algorithmic bias and implementing methods that help mitigate it. And that's part of the reason why HMDA data is made publicly available. It helps show whether or not lenders are serving the housing needs of their communities. They give public officials information that helps them make decisions and policies, and they shed light on lending patterns that could be discriminatory. HMDA data is an awesome data source to analyze and model from, but it also suffers from quality issues that creep into the data. And here's one example of a rate spread where the decimal point is probably in the wrong place. So with data errors and bias prevalent, we'd love to welcome you to our solution. Fusion PreCheck is a machine learning-based API solution that helps financial institutions who upload data to HMDA ensure that their data is high quality and that no poor quality or incorrect data points slip through the cracks. So in the fight against algorithmic and data bias, it also lets institutions understand their data in fractions of a second and let machine learning help them identify any potential bias. Let's look at a couple endpoint examples from our API. So our error scan endpoint uses machine learning to understand what good high quality HMDA data points look like, how the different numerical columns interact, and what their values should look like. So the endpoint takes information from a loan application record such as loan amount, loan to value, rate spread, interest rate, income, and more. And then this data is passed to a machine learning model that predicts if the loan record has any potential errors. And if so, then it's passed to a secondary statistical model to understand and flag the columns with potential errors. For example, in the response that you see here, we see some potential errors like a loan amount where someone accidentally hit a few extra zeros, or a missing property value, and a clearly wrong interest rate. The idea here is that we can leverage machine learning to do more for field correctness and help institutions make sure that they're uploading high quality data before submission. The bias scanner is another machine learning based endpoint that helps institutions scan their own data for potential bias. They post loan application record information, and a machine learning model is fired off in real time. The model looks at all of the approved and denied loans to understand their characteristics. It then does matching based on loan information and checks against sensitive attributes to see if they're different among the applications. So looking in the sample response, we see that one loan record was recommended for a second review based on its loan details. The ethnicity and the race were deemed suspicious based on other very similar loans that were approved. So this endpoint lets financial institutions find bias in their data without needing to perform hardcore data analysis with their own development teams. Data is power. It holds the key to understanding and insight, but insights are only as good as the quality of the data. Fusion PreCheck is an analytical lens that will ensure that high quality data is available for analysis and help institutions understand where there may be some potential bias hidden in their data. Fusion PreCheck is a one-way ticket to high quality data and understanding of bias. So now APIs are awesome, but looking at a Postman collection can be a bit boring. So we decided to create an application that's integrated with our APIs. So let's take a look at how these APIs can be used and some cool things that we could build from them. I'm going to pass the ball to Hannah for this one. Oh, sorry, 1 second. Here we go. All right, Hannah, you should have the ball now.
Yep. Thank you so much, Alon, for that great introduction. And I am going to show you guys the application we built that calls on our applications. So this is Fusion PreCheck, and here we can upload our data. So here are some data points that are altered data points from real data we downloaded. So we upload it, and then let's go check the quality of the data. Oh no, it looks like we have 13 potential entry errors. And here are some of the flagged fields. Now, one thing to note is sometimes it flags the fields based on their large values or small values, and sometimes it flags them based on an unlikely combination. So while it might be a fine loan value and it might be a fine LTV, if then the property value doesn't match that, it'll still flag it. So let's look at an example. So let's look at record 55. So here we can see the full data, and on the right we just see the codes mapped to what they mean. So here we've got an originated loan, and it looks like someone might have added a couple extra zeros. And it's saying maybe you should look at some of the other fields to check that. And here we see that the property value is $750,000. So likely this loan amount was supposed to be $650,000, and someone forgot a decimal point. So let's go look at our bias check. And here, this is great. This data doesn't have any bias, and so we're good there. But let's go look at something that does look a bit biased. Uh-oh, this one has 30 total out of 1,600 data points. Now, don't fret. I made these ones up. There's not an institution that's this bad. So let's look at an example of one of the biased data points. So let's see. Let's pick 600. Okay, so it thinks that both the sex and the race might be a little suspicious. So we see an American Indian, Native American woman. So let's go look at some of the other stuff. The loan was originated. It's a conventional loan, first lien, and this woman is only asking for a loan amount of $55,000, and the property value is $395,000. So a pretty good LTV there. It's a primary residence, and her income is $125,000. So that looks like she should get a pretty good rate. But then when we go and look at the interest rate, she's getting a nearly 6% interest rate. And that seems like it might be wrong. And someone might need to review that to make sure that she is getting a comparable rate to her peers. So that is an example of our APIs in action on our platform. In addition, you can, oh, it's loading. The data quality check on the larger data set takes a while. But you can also export all the data, and this will be just the errors. So if you want to look at those 263 potential errors. You can just click there and save the data, and then you can analyze that on your own time instead of using it in the app.
And so we're right at 10 minutes. So
all right, I was about to pass it back to Alon for questions. I'm just trying to figure out how to get there.
Just drag that little ball to my name.
Well, I need to stop sharing. Okay, there we go.
And if the panelists have questions, just raise your hand.